My name is Keith Wozleski. Welcome to Space Science class number 8. This is on probably one of my favorite topics here on Slooh. We're going to talk about stars today. I say this every time it seems that we're talking about something on Slooh, but if Slooh does one thing well, it is this. It is stars. I mean, just fantastic. We're going to begin by looking at a couple star images, and then we're going to go in and talk about what stars are and the life cycle of stars. But, if you schedule a mission to a star on Slooh, and they appear in your drop-down menu alphabetically by their common name, there are loads of stars in the Slooh 1000 that you can look at. This is just one of them, Alpha Canis Major. Beautiful, beautiful blue-white hot young star with this four crisscross pattern in the center. We're going to look at another one, a little bit smaller, Beta Orionis, Vita actually Orionis. The same pattern, nice hot blue-white stars. Hot meaning blue-white means that their temperature is higher than some other stars. Here's another one. This is Regulus, which is the brightest star in Leo, Alpha Leonis. And we have, I think this one, yes, Alpha Tauri, Aldebaran. So if you notice, just by looking at some of these stars, we have different colors. Stars will appear differently depending on their life cycle, depending on their temperature. So stars do have a life cycle. If you remember when we were in Orion, we looked at that beautiful star forming region, stars that are not even really formed, fully formed yet, baby stars. And then we enter into the period of life that we refer to as main sequence stars. This is when stars are creating helium at their core. They're fusing hydrogen because of their immense mass, creates a lot of intense pressure, and hydrogen atoms are fueled into helium, and it is basically a giant nuclear furnace. If you want to learn all about the process of nuclear fusion, you can go to start with the sun. There are 3 or 4 excellent sun quests because our sun is a star, and you can learn all about how the process of making fuel for itself occurs in our very own star, the sun. And then you can take the quest Life and Death of Stars, where we learn about the life cycle of stars. So that main sequence stage, star is very healthy, forming helium at its core, bubbles up into the surface, and there is an equilibrium between this immense pressure pressing down into the core, and the core, of course, is bubbling outward as it generates heat, light, and radiation. And then we reach a point again where the main sequence has ended, where we begin burning other materials. The star basically starts consuming itself. That equilibrium is broken, and the core starts to expand outward, causing the star itself to expand. The size of the star will determine how a star ends its life, and we'll talk about stars at the end of the life later. But I think that's the big takeaway here is stars are beautiful here on Slooh. Slooh does a wonderful job. If you notice, stars will appear differently depending on the telescope that you choose. This is where telescope choice becomes important depending on what it is that you want to see. I happen to like this crisscross pattern. We call those diffraction spikes, and that has to do with a central obstruction, the secondary mirror on the telescope. I don't want to get too technical. Not all telescopes on Slooh will give this type of pattern. If you've seen James Webb images of stars, you will see 6 of these spikes, and that's because it's a different type of telescope. It's actually like a composite telescope. But here we have the 4 crisscross patterns. I happen to really, really enjoy this. I think it really gives the star uh, some some body and some composition and some texture, if you want to think of it that way. But not all telescopes do this. So if you do like that crisscross pattern, you want to be on Canary 1, Canary 2. Canary 3 and 4 are also available for stars. They usually don't give this pattern. So in a nutshell, stars are giant nuclear furnaces at various stages of life, depending on their age and what's happening with them, whether they're very dynamic, whether they're not even really fully formed yet, whether they're very dynamic in that main sequence stage, or whether they're approaching their end of life cycle in this red giant phase. And we can see the difference very visible right here on Slooh. Here's another one. Alpha Orionis, I want to talk about scheduling star missions and what these names mean. So, if you notice when you schedule a star mission, we can unpack this a little bit. You will see two names. The first name is usually its common name or sort of a colloquial name. And then after that, you will see two words, the first of which is a Greek letter, and the second is a Latin form of the constellation. So the Greek letter tells us how bright the star is relative to the other stars in this constellation. So if we look at Epsilon Cassiopeia, the constellation is Cassiopeia. Epsilon is how bright it is. That's several letters down in the Greek alphabet, so it's not the brightest star. But here we have Sirius Alpha Canis Majoris, Alpha Canis Major. So it's in Canis Major. It's uh, in that constellation, the dog, right? The dog star. It's Alpha, the first letter in the Greek alphabet. It is the brightest star in that constellation. Sheraton Vita Arietis, so that's in Aries. It's the second brightest star, Alta Vita Gamma Sagittarius, Gamma Voitis, so that's in Voitis. Gamma is the third letter, Alpha Vita Gamma Delta, Lambda goes on like that. So when you see these star names, do not be afraid of them. We don't always use uh, the colloquial name. And in fact, I wish we didn't use the names as much. I find it much more informative to know which constellation we're in and how bright that star is relative to the other stars in that constellation. Why do we have different stars and different relative brightnesses? It's because of this. So I'm going to look at my handy star size image. And as I mentioned, there are quests that explore all of these things. Certainly, Life and Death of Stars is a must-take quest. If you've never taken a single Slooh quest, excuse me, you want to take that one because it talks about and teaches us that stars, again, do have a life cycle. You also want to take some of the quests that relate to the sun, especially those concerning how the sun makes fuel for itself. Very, very, very important because that goes back to also the life and death of stars. Depending on the size of the star will determine how it ends its life. Our sun here, shown in comparison to its size with our planets, looks enormous. Our sun is actually fairly small in the stars that are visible to us. It used to be thought that it was smaller than most. Now that we have better equipment, we know it's actually kind of average size, but the sun does classify as a yellow dwarf. Uh, and whenever we look at stars on Slooh or anywhere else, we're looking at objects that are in our own Milky Way galaxy. We do not see or are not able to resolve stars that are in other galaxies. We're looking at stuff that's in our own galaxy. And here we have our sun. We are going to look at it in comparison to Sirius, which is it appears very, very bright in the sky, but it's not that large as we're going to see compared to other stars. So we see our sun, the planets to scale. Sirius definitely larger than our sun. Sirius, a blue-white star. That tells us that it's young and kind of bright. We compare it to Pollux, kind of in its uh, red giant stage. It's swollen. Our sun will also enter into a red giant stage and will begin consuming the inner planets, probably getting as large as or getting as large to where it moves out into the orbit of Earth. Will certainly swallow up Mercury and Venus. And that's kind of where Pollux is now. We're starting to see our sun relative to other stars that are out there, kind of small. Arcturus, another red giant, our sun by comparison. Arcturus Aldebaran, another red giant star. Rigel, a blue-white star. What's the difference? Aldebaran at the end of its life, Rigel, very, very healthy. Still a main sequence star, very bright, very hot in terms of temperature. When a star reaches that red giant stage, it does cool down somewhat. So again, we're looking at sizes. Rigel, Aldebaran, Betelgeuse, 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 three pronunciations, common pronunciations of this huge uh, red giant, larger than some of the nebulosity that we see, some of the clouds of gas that we see in space. I mean, just enormous. Here we see our sun. Our sun is a dot compared to this. Wow. Okay, so I'm going to go back. I'm going to end it here. When we look at stars, we can talk about two things. Um, how big they are and how close or how far away they are. So if you go into Stellarium and you click on a star, you may see magnitude and you will see absolute magnitude. So absolute magnitude refers to what we're kind of looking at here, the size of the star compared to other stars. And that has a numerical number. The smaller the number, the bigger the star is. So stars that are in the negative numbers in terms of absolute magnitude are actually larger than, say, a star that's magnitude 20, which is actually very faint. Then we have the idea of how close or how far away something is to us. So a star can be relatively small, like Sirius, but it appears very bright to us because it's closer to us. And then we can have stars that are absolutely enormous, but don't appear all that bright because they're so far away from us. There is a Slooh quest that talks about this. I think it's called How Near, How Far, and it explores this idea. So the absolute magnitude tells us how big it is. If again you're in Solarium and you hear about the magnitude or sometimes relative magnitude, that's how bright it appears to us in the night sky. So a star like Sirius, again, appears to be very bright, but it's actually fairly far away from us. It appears very bright because it's very close to us. When we look at these magnitudes on Slooh, we can go down to about a magnitude of 20, which is fairly dim. Does that mean the star is small? No, it just means it's dim. It can be enormous, but it can be very far away from us. Okay, I think that's all I want to talk about here with stars. I want to go into this. I've got another diagram here. Closest star. So we look at our sun. That is actually the closest star, and the distance from the Earth to the sun is referred to as an astronomical unit. That's just so we don't have to keep using numbers that have a lot of zeros off of them. The closest star apart from that is we get into this Alpha Centauri at Proxima Centauri group, where we're at about 4 light years from us. And we go from there. So these are stars closest to us in the Milky Way galaxy. Remember, where we are is in this spiral arm down here. We're about a third. We're in that Sagittarius arm, I think, of the galaxy. So we're seeing stars in that last diagram in this general region where we are. What about the other end of the galaxy? Well, we can't see through a lot of the dust lanes and things, so we don't always know what we are when we're looking edge on, but we can see some objects. They're very far away. So you can kind of see what I'm talking about here. An object that isn't necessarily that large can appear very bright to us because it's close to us. If you're all the way over here, you could be enormous, but you've got the entire span of the galaxy, so you're at a much greater distance to us than we are. All right. I think I want to go back to this diagram here. We're at 15 minutes. I'm going to take a quick break. Gretchen, do you have any questions, or do we have any questions in the chat here while I take a sip of water?
No questions just yet, Keith. This is so great. I'm loving all the star stuff on Slooh and everything that's available to check out.
Yeah, I make no secret about the fact I love stars. Yeah, I love all the Slooh objects. I love everything in the night sky. But stars to me just have that quality, that gem-like quality. I mean, when you look at this, they are just very bright, very brilliant. When we look at clouds of gas, when we talked about nebulosity, um, a lot of the nebulous clouds need to have some type of processing because the clouds are dim, they're faint, they can be underwhelming unless you do a little work to them, not stars. You point the Slooh telescopes at a star, you're going to get something like this. They're pretty spectacular. Okay. So we talked a little bit about life and death of stars. We talked about stars. We're going to talk about this. So this is a diagram, or I should say, a photograph of Meyer's observational notes where we see some other stuff going on. We've got these little graphs, these little grids, and we see not one, but we see two stars, and that takes us into the world of these double stars. So this is a Slooh image. The person did not put the Slooh logo at the bottom of this. We do ask that if you make any type of manipulation to a Slooh image, that you go back and use the telescope specific tag. There's like a little insert that you can put, and maybe you see these on Slooh. That lets us know two things. It lets us know, one, that you did manipulate the Slooh image. This is not straight out of the camera. They did like a little insert. And it lets us know what telescope you used. I can tell this is probably a Canary 2 image because we see, again, the diffraction spiking, but we see not one star, but two stars. This is Vita Cygni. So what does that tell us? This is in the constellation Cygnus, and it's the Vita. It's the second brightest star. The common name is Albireo. So here we have not only two stars, but two stars of different ages. We have a blue-white star, which is the companion, and we have a brighter orangish star, which is a star in the red giant phase. Um, when we look at stars on Slooh, or stars in the night sky, double stars or multi-star systems, because you can have more than two, are not the the exception. These are actually the normative arrangement of stars that we have. Single stars are actually the more rare version or variety of stars. Most stars are double stars or triple stars. So that's something to keep in mind when you look at the Slooh telescopes and we see our star categories. Don't just schedule missions to single stars. Look at some of the double stars, and there are double stars buried into the single stars too. Sometimes we get a double that hasn't been isolated, but we see this. Two stars, two for the price of one, relatively close together in our frame of view. Alvario is not believed now to be one star in orbit around the other, like some of the others that we're going to look at. It's now believed that Albireo is an accidental double. What do I mean by this? It means that just because of the position of the Earth and the position of the stars in the sky, they just kind of look close together because of where they are. We see this with the moon. The moon goes through its cycle every month, and sometimes the moon will appear to be very close to a star, very close to a planet. They are nowhere near each other. They're light years apart from each other, but because of the positioning of the two objects, they appear to be similar. I'll use a perfect example. I'm in my room here. I've got a microphone about 2 feet away. I have a wall that's about 15 feet away. The two objects are nowhere near each other. The lamp right by the wall is nowhere near the microphone. It just appears to be close to each other because of where I happen to be sitting. All right. Albireo, one of the most famous double stars in the night sky. Very easy to see, even in a small telescope on Slooh. Always fantastic, regardless of which telescope you choose. This is another one, again, black and white image. One thing, well, there is some color. I want to get back to this for just a minute. When we are on Slooh and you see stars close to each other, usually you can tell by the diffraction spiking that this is in fact a double pair. Now, even though these aren't very close together, probably we still do see the double diffraction spiking. We're going to see that in some other examples. This is me, Scorpii papyrima. This is an image that I took. Um, I did a little bit of work. I cropped it. This is how it looked when I ran the mission, but you can see very clearly two stars. These were, I believe this is a naked eye object, and I did a beautiful observation on this, a write-up about what the Polynesians had believed about these stars. They believed that these were actually twins, brothers and sisters, and there's a beautiful mythology that goes along with this. But this is very definitely a stunning uh, double star pair that we can see with the Slooh telescopes. Alpha Crucis, so again, the brightest star in Crux. This is the Southern Cross in the Southern Hemisphere. Here we see very clearly the double diffraction spikes and these two beautiful double stars, not one star, but two, right? We look at a couple more. Ah, the double double in Leo. Now we think about the double double. So here we have a double star system, and each star itself is a double. So we have not just a double star system here, but the star also has a companion. So this is the very famous double, well, not as famous double double, the double double in Lyra we're going to look at the very end. But we have this is sort of phenomenon too, where we have double doubles. So we don't just have a double star, we have each star also as a companion. This is also a mission ran, I don't know, a year or two ago, um, because I don't see this a lot on Slooh. I don't see people scheduling missions to this. It's a great, great object. And again, we see the double diffraction spiking because this was probably a Canary 2 image. That was just a Stellarium thing for the double double. Here's another one, a double star. Again, you see them very close together. And here we have a triple star system. One, two, three. Again, you can see you get some help. That star is not just a blob. We get some of the diffraction spiking. It doesn't appear to be three independent stars, but they are there. We get a little bit of help from the lines. And as I mentioned, I encourage you to go through the double star list and have some fun with these. Um, Apart from what we see on Slooh, there are thousands of double stars that have been identified. And it has to go back, or it has to do with the way telescopes had developed. In the beginning, we did not have these enormous light buckets. We did not have telescopes like Canary 1 that is a half-meter telescope that can collect all this light. Telescopes, for the most part, were kind of small, and at least in terms of how much light they were able to collect. And because of that, they were good for the moon, they were good for planets, and they were also good for this, for double stars like we've been looking at. And that was the realm of astronomy for quite a while, at least until the 18th century, where we started to get a better glimpse of some of the nebulosity. And this is an image of Groombridge 34. This is another one of my missions that I took. I got this star from a description from an 1820 publication. I think it's a reprint. That was not even from an astronomer. It was from very much an amateur who wrote a book, mostly double stars of what he would find at night just by going out in the night sky and looking around. And I encourage you to look through some of these older lists because they reveal gems like this. And usually there is a description. It'll say, these are the coordinates, and you're going to see two reddish stars. These are important, I think, to me because these are red dwarfs. We don't see this type of star very often anywhere in the night sky, but here we clearly see a pair of them right in the center. And these double star lists, again, thousands upon thousands that you can get for free. You can download them. Sometimes they have coordinates, sometimes they don't. You should, depending, regardless of what type of membership you have, you should be entitled to at least one advanced mission, which is a coordinate mission, and you can schedule it by coordinates. Here, I schedule it by the SAO number. Stars have a number of different classifications, even though it's the same object. Here, I did it as an SAO, but again, a beautiful, beautiful double star. Uh, that is very rewarding to look at. Like I said, you can look at these all day. They're all different. They're all great. Just beautiful, beautiful objects. And one of those kind of acquired tastes, I guess. Here we have another set of doubles. Again, we'll just look at a few more. Some light coming here from something. I don't know. That could be a planet nearby or the moon. Um, What else do we have? Okay. So resolution of double stars. Let's say you go through that list and you don't see a clear separation. Well, that has to do with a number of things. Sometimes we need a certain degree of zoom or magnification in order to split or have the double star resolved. So let's look at this little sketch here, this little diagram. You could have a double star that appears as one star. It's unresolved. Then if we increase magnification, or depending on how far away it is from us, the star may appear elongated. Why do I say depending on how far away it is from us? There are some double stars that you cannot resolve, okay? They're just too small or too far away or whatever, and you will never get resolution. And that's why some of these double star lists are great because it lets you know what you can resolve and what you can't. So sometimes you may only get this, you may only get an elongation, you may never get this clear split where the stars are clearly separated like we've been looking at. Sometimes you'll get what we call partially resolved, where you have this little indentation or a notch in the middle. Sometimes the weather conditions, seeing, can have something to do with this. We're going to look at my last example here, where that played a part. But don't be discouraged if you start scheduling double star missions and you cannot resolve them. That's not something that uh, is an issue that has anything to do with our equipment. Some stars simply cannot be resolved. We know that they're doubles through spectral analysis, but we can never get a clear split or definition. It's no one's fault. It's just the nature of the star. What we want to look at are the ones that we can split and the ones that give us that beautiful definition that we have. Probably the most famous double star after Alberio, at least certainly the most famous double double, and this is the double double in Epsilon. I'm sorry, Epsilon Lyrae in Lyra. When I looked at this, I thought we had some separation. Actually, we don't. We've got some blur, and that's coming from wind. So when I looked at other images of this, uh, I wasn't getting the split, and I know now why. Because here we have some wind. Uh, I haven't been able to split the double double in Lyra with Slooh because we see separation here, or we see some a bit of a dent. That's because of the wind. How do I know that? Because look at the other stars. See how there's a trail behind all of them. So either every star in the image is correct and we have a split, or there's something else going on. That's why everyone looks that way. We've got a little bit of wind. So an example, we actually don't have a split here. We have wind. Okay. There are other types of doubles on Slooh. Perhaps you've seen this quest, the Demon Star. Algol. Here we have something that we call an eclipsing binary star. So we have the main star and we have a star in orbit around it. So it is kind of a double, but we never are able to split it as a double. Instead, what we see is a change in the brightness of the main star as the companion passes in front of it. It is an eclipsing binary star and has a very short eclipse period. I think it's only 3 or 4 days. So this is Yari Blackman image uh, that I've taken from Slooh from one of his observations. When the star is at its brightest, we consider that to be its maxima. When it's at its dimmest, that is minima. We clearly see it here getting brighter, then getting dimmer. Dimmer is when the other star, the companion, is passing in front of it. That's the way we identify, actually, a lot of eclipsing binary stars is by seeing whether or not it dims in its brightness. Algol, known to the ancients, known to us since antiquity. How on earth they knew this, I have no idea. You have to imagine a world where we didn't have any light pollution, so the sky was just black. In very dark sky environments, you see a lot more stars than you see at home. How they would even know this star got dimmer and got brighter, I have no idea because there are so many other stars. The picture doesn't really do it justice, but we do see the brightness and the dimming of the star. Again, this is from his quest. Uh, yeah, you're right, Backman. Again, this wonderful, wonderful image of Algol, the demon star. And like I said, you can schedule your missions on Slooh. There's some help in the mission scheduler within the quest. Great quest. This again is another must-take star quest if you haven't taken it already. Algol. Just cover a few more doubles and multi-star systems here. We're starting to see more than one again. We're seeing some other stars in the vicinity, whether gravitationally bound or not, I forget. But again, we see this phenomenon of double stars. Lots of doubles I'm sharing today because I happen to really enjoy doubles. They're great. We're going to look at one other thing here. I guess we'll look at this now. Here's another little project that we can use the Slooh telescopes for, and that's regarding Sirius. So and Sirius, again, is one of the most popular stars in the night sky. It's very bright, certainly very popular here on Slooh. Sirius has a companion. There is Sirius and there is Sirius B. It is not always visible, but if you notice, right now we are in a position where Sirius B is far enough away from Sirius that it looks like we should be able to see it with the Slooh telescopes. You can see this at home if you have a pretty powerful telescope. I've seen many images of Series B. The one thing to notice here is that on Slooh we use a corrected image. This image is not corrected depending on the type of telescope that you use. Images can be reversed. They can be upside down. They can be upside down and reversed. Of course, there's no up or down in space, but when we think of the moon, we get accustomed to thinking about the moon the way we see it. If you were to look at it through binoculars, if you leave Earth and fly to the moon, everything is kind of in one particular orientation. That wasn't always the case. A lot of old moon maps had the moon reversed, and sometimes you'll even see it upside down. They did that to accommodate the Apollo astronauts. So with this, we actually have to flip it around and do something like this. So we have north, south, east, west. Sirius, the companion should actually be up here somewhere. And this is a definite confirmed image. This is not a Slooh image, but we see Sirius B very clearly shown in this picture. This has been brought up before several times on Slooh, and I've never seen conclusive evidence whether or not we have seen it. I know we've tried it, and we've seen some incredible things. Certainly with Mars, where we've seen Phobos and Deimos, which are basically rocks. They're not really moons that are in orbit around Mars. We've seen people use the telescopes and play around with settings where we've been able to see that. I have not seen the Slooh telescopes used where we have seen Series B. I say that it could be done, and I challenge everyone here to figure out a way for the settings. Every time it seems that this comes up in conversation, it just kind of gets dropped and forgotten. I don't know how diligently people are out there trying to see if they can see Series B. It's very good now. It's going to be good for the next couple of years. So this is the time to to do this if you are so inclined. I want to look at something else here. I've got to go into my solar system scope. And that has to do, oh, you know what? I got to get out of this. Sorry, sorry, sorry. I have to do that as a special share. Sorry. Portion of screen. Okay, here we go. So I'm going to shrink this down. And we talk about these double star systems. One star is usually in orbit around another. So I'm going to put these in motion. And this is the star Theta. And this is why I don't like colloquial names, because that doesn't tell me anything. It doesn't tell me where it is. It doesn't tell me how bright it is. But what we're going to look at today is just the orbit of the companion around the main star. So if I zoom in here, you can see it. And the star is in orbit around it. I don't know the size of the stars, but if this is accurate, I know that we see two types of stars. We see a yellow, red giant, right? It's reddish, orangish, and we see a very hot blue-white star in the center. The companion is in orbit around it. And I want you to look at the distance. Our closest star, Sirius, not Sirius, that Proxima Centauri group, about 4 light years away. Here, these two stars are 10 astronomical units away. That's very close. Remember, 1 astronomical unit is the distance of the Earth from the Sun. Jupiter is 6 astronomical units from the Sun. 10 astronomical units is like Saturn. That's the distance from Saturn to the Sun. And if we look at some of those diagrams that I showed earlier, these stars can be absolutely enormous. So we can look at something like this where we have one star in orbit around another. This doesn't really give us a sense of scale. The stars can be actually very, very large, and they can be moving very, very quickly. If you notice my time clicker here, I advance the time a whole lot. We're in the year 2105 already. That's not the case. We looked at Algol. We have an orbital period of 4 days. So There's a huge variance in the size of the stars and in their orbital relationship. So just because we have a very slow orbital period here, that's not necessarily the case. They could be moving very, very quickly through space, almost like two balls in, as I said, they can be absolutely enormous. So I just wanted to look at this when we look at our double stars, although they appear to be stationary to us, this is in fact what's happening, spread out over usually a very long period of time. We looked at the diagram again of Sirius and its companion. It could be a very long period of time. Those stars may in fact move, but we might not see any movement for many, many years after today. Sort of like the way we see the movement of the moons around Jupiter or around Uranus. Those move very quickly, but that doesn't necessarily have to be the case. We may never detect any movement in our lifetime, like we're looking in this diagram here. That doesn't mean that the star is not moving. Okay. So before we wrap things up, I want to take a look at one last thing. We talked about the life and death of stars. And I had mentioned that depending on the size of the star, that will determine how it ends its life. So a star the size of our sun will end its life by entering into the red giant phase. It will suffer core collapse and will become a white dwarf with a planetary nebulosity around it. It will become a planetary nebula. Some of the larger stars will end their life in some type of nova event. And here I have some images of what a nova, supernova, looks like on Slooh. This is from the Whirlpool galaxy from, I think, 2 years ago, M101. And we can see here, again, this is where the nova is going to appear. It's in this spiral arm down here. You see nothing, we see nothing. Then all of a sudden, we see this. We see the appearance of a dot. Now, whether this is actually in the Whirlpool galaxy itself, or whether it is just kind of, again, an accidental relationship, it doesn't really matter. The fact is the star is going to appear as this dot. It's blowing up in some form. And there are different types of nova events. We're not really going to have time to go over those today. You can certainly research them. I just want you to see what it looks like when we see them on Slooh. These types of events happen all the time. Again, we see it right here. I think I have an animation that I did. Here again, we see it before there was no dot. There's a secondary dot. This is the way it's going to appear on Slooh. Here's one animation that I did. So before and after, you have the no dot, and then you have the dot where the dot appears. That is the nova. That is the star basically blowing up. I have it here in black and white. Sometimes when we reverse the image, we get a better idea. Very, very clear here, very visible. You can see the dot. I have another image here. In fact, let's go back to M101. This was, if I'm not mistaken, discovered uh, in Hawaii, and somebody posted on Slooh, "Hey everybody, there's a nova event that's happening in M101." Why is this a big deal? Because the Whirlpool is one of the most famous galaxies that we have. Famous in the sense that it's very easy to schedule missions to it. It's easy to kind of go out and look at with the telescope. It's a very popular spot. It's very famous. So to have this type of event in one of the most famous galaxies in the sky is a big deal. Anyway, person put in a little note and said, has anybody witnessed this or seen it yet? Well, because it happened in Hawaii, we weren't really able to see it yet. But a bunch of us had scheduled missions for it that evening with the Slooh telescopes. And within, a few hours of its discovery, people on Slooh were already observing this event. It didn't become popular discussion in astronomical circles until a couple days later. I think it happened over the weekend. So it wasn't until like Monday or Tuesday of the next week. And we on Slooh that knew about it, we're already scheduling missions to it. So just to give you an idea, of where we are in terms of the community at large, we are doing some incredible work as a group here on Slooh by keeping abreast of kind of what's happening in the night sky. And this was a perfect example of this. We were talking about this, and we're kind of like been there, done that, before most people even knew it was happening. And that's because of a comment that somebody, a very astute member, had published somewhere on Slooh, and a whole bunch of us ran out and started scheduling missions to look at it. And this was the result. This was another event. This happened in M85, which is an elliptical galaxy. That's not the best animation. I was still learning to animate when I made this one, but it was the same thing. I've never seen a supernova before, or a nova type event. This is where it is. Can some people check it out? And here we have the same thing. No star, and then we kind of have this star. The nice thing about this was there is an agency, and we talk about this all the time. On Slooh, we have the Minor Planet Center where people track asteroids and report to the Minor Planet Center. There is a group at the University of Rochester that keeps track just of nova type events, supernova events, stars blowing up. And I had actually submitted my pictures. You can do this. They have a website. I didn't do a lot with website pictures because they changed things around a little bit. It's a little more difficult now than it used to be. But there are two email contacts. You take an image of your supernova event or nova event, because they're a little bit different, uh, and you send it to them. They verify with what has been observed, and they will put your name on the list as a person who has observed the event. And that's kind of what I did here. Anybody can do this. It's kind of exciting. It's fun to be able to reach out to an agency that keeps track of these things and say, hey, yeah, I saw it. And of course, they accept using the Slooh telescopes, remote telescopes, for observations like this. So this was the M85 supernova event. This is from a couple years ago. But as I mentioned, these events are happening all the time. It's just a matter of knowing where they are and scheduling a mission to it and having a before image. It doesn't mean very much if this is all you see, if you don't have something to compare it to from before. So you really do need to kind of have a before and after image. If you don't have a picture of the object where the event is happening, not a problem. You use the magnifying glass feature on Slooh, and you just look up a before image, and then you automatically have your before and after. You don't actually have to have uh, a mission that you scheduled yourself. And I think that's about all we have today on stars and no events and life cycle of stars. I'm not going to talk about what happens with a star, how it ends its life. That's something that you can look up on your own and learn all about when you take some of these quests and find out what happens when a star runs out of fuel and begins to consume itself and either turns into a planetary nebula like our sun will, or ends its life as some type of nova event, some type of, because there are different types of them, and you can learn about those too in the Slooh quests. That's all I have for you today on stars. My name is Keith Wozleski. This was Slooh Space Science Class number 8 on stars. If you have any questions, you can reach out to me on the Star Party page or drop me a line in Discord. And thank you for being with us today. Again, my name is Keith Wozleski. We will see you next time. Have a great day.